Hello, everyone. I'm Cohen Hoffman. I am from the online section of object-oriented programming, and this is my final project presentation. Has to be like the 12th take I've taken of this thing because it's been really long a few times, so I got to shorten it, and we'll just see how it goes. All right. So I decided to make a plant identification mobile app. I have it running here on an Android emulator. I'm on my desktop computer because I need a GPU in order to run the Android emulator efficiently and quickly, so it doesn't take like half an hour to, do one identification. But here's a demonstration of it. We use C# and we use XML, .NET MAUI. That's how the UI is built. It is a cross-platform application where you can make Windows apps and mobile apps, and I thought that was pretty cool. But anyways, so what we're going to do is, here's a little demonstration of it. We're going to select an image. We're going to put in a tiger lily or an orange daylily and see if it can correctly identify the plant. So we click identify here, and we're going to wait a response from the Gemini API, which is the backend on how this works. There we go. We got our orange daylily. That is correct. Different varieties of it, too. I particularly call this the tiger lily, but now what we're going to do is we're going to test out the detailed results part. So we're going to get some pretty detailed results about a dandelion. You all know what flower this is. Invasive as all get out. One of the most invasive plants on the planet. There it is. With 90% confidence, it says it's a dandelion. Ooh, it actually has quite a few that it thinks it is. But with the detailed results, we will get if it's a weed, which it is. If it isn't invasive, absolutely. Is it poisonous? No. And then is it household safe? True. Dandelions are household safe. This is pretty much the extent of my project goes. It's kind of relaxed for that. So, anyways, first off, we're gonna see my plant ID UML diagram. We have our base identification class, which is abstract, which base result inherits from, and then we have detailed result that inherits from base result. Detailed result cannot exist without base result, and base result cannot exist without identification, but I didn't put it on here. We also have our reusable identification card and detailed identification cards. We have our image processor class. We have our Gemini client class that implements the interface of Gemini interface, and then we have our main page that takes care of all of the connections between the classes. So moving back into the code, we have XML that's used to create the UI, but that's less important than the object-oriented side of things. So first off, we're going to take a look at base identification. We have our abstract class, so this is just a blueprint. It's not instantiated anywhere. We've got simply our common name and our scientific name as properties. We have base result, which inherits from base identification. This has the field of confidence percent, the property of confidence percent, which is encapsulated right here. We basically want to constrain the values between 0 and 100, which that does here. And then we also have a short description. And then the third class in the identification line is detailed result, which inherits from base result. This contains household safe, poisonous, is a weed, and is invasive properties, which are all Boolean values. And this is basically just what the detailed results are. Okay, moving on, we have our image processor. The image processor basically takes images and turns them into something that the Gemini API can interpret, such as byte arrays right here. We take string paths and we'll turn them into bytes. And then we will also take image sources from the UI and turn them into bytes and send them to Gemini. Okay, so now the most exciting classes. We've got our Gemini interface. Quite simple, but this is one of the extra credit opportunities I decided to go for. It's very simple. Like, we have async on image, so if we wanted to change the functionality of this, we absolutely could. We can override it in Gemini client. So Gemini client implements the Gemini interface and iDisposable. We have our properties of Gemini client and the different prompts we can give it. Basically, it holds the basic prompt and the detailed prompt. We have our properties that are response, is busy, and then list response, which is what Gemini gives us as the identifications. And then detailed prompt, which is a Boolean if we want a detailed prompt or not. We have our generation config that controls how Gemini responds. We have our constructor that sets the new Gemini client with our Gemini API key. No, I will not show you that. Only the professor can see that. I'm going to deactivate that key anyways after the project is graded. And then we have dispose, which completely frees the memory of Gemini client after this class is disposed of. Now, the most exciting function out of the entire project is our asynchronous task, which is on send image. And this is the implementation from Gemini interface. Basically, what we first want to do is set that it's busy. And then we want to set our system instruction on whether or not we want the detailed prompt or the basic prompt. We then want to set up the Gemini instance with our model, our generation config, our prompt, and then the image that we give it. Yes, the syntax is kind of ugly here. And then after we get our response, we're awaiting the response here. After we get this response, we're going to take the JSON response and we are going to turn it into a class that we can use. Basically, Gemini responds with JSON, and we can convert it into a class that we can use in an object-oriented way, which is actually kind of cool. A lot of programming languages and frameworks allow you to do this, such as Flutter and Dart. Kotlin and Jetpack Compose allow you to do that too, which that's pretty cool. I've done that before with both of them. Anyways, moving on, we're going to go look at our UI views. We've got our XAML here that uses bindings to collect data from the classes. We have our code file here. We've just got one property, which is plant data, that we can show in each card. Identification card basically does the same thing, but with the base response instead of the detailed response. This is like some sort of implicit polymorphism, because if we look here, every card is the same, except the data is different. The names are all different, the scientific names are all different, and then the descriptions are all different. And then now we're going to take a look at the class that holds everything together, which is our main page. This is where our Gemini client is utilized. We are going to save a selected path to the image, and then we can set if we want detailed results or not. Basically, this file mainly holds events. Like on identified click, this is where we will utilize the Gemini client to send the image and get a response. Then what we're going to do is we're going to turn it into something that we can use. If it's a detailed result, we want to use the detailed result class. And if it's a base result, we want to use the base result class. And then we do have a bit of an error handle here, and that's a try catch. If Gemini doesn't respond correctly, it's going to say the identification failed with any message that's given. And then no matter what, we want to show that the response is complete, and then we want to show them on the screen. On select image is basically when you click the select image, it's going to open the media picker. And then there is a check here for error handling. Basically says if there was or not a photo, the photo that was selected. And then on detailed switch basically toggles whether or not we want detailed results or no detailed results. All right. So there's a lot of things in this project that connect to object-oriented programming. I've shown you encapsulation, inheritance, a little bit of polymorphism, abstraction, and then interfaces. So there were a few problems that I had making this app. Asynchronous tasks are no joke. More than likely, you're going to run into them at some point, especially when you do things over networks where you have to wait for responses. It's also kind of like a parallel computing thing. Like we have our async on identify clicked here. Basically, while we're waiting for an identification, as you've seen, it's going to say identifying, please wait. And then once we get a response is when we show what the identifications are. But anyways, well, I had it up here, but I have the GitHub. If you guys want to see the code, I will slap it in the discussion. I was going to put it in this video, but I'll just slap it in the discussion. I thought this project was really fun to make. I had a blast making this project. I come from an object-oriented background. There's a lot of things I already knew, but I still ended up learning a lot of new object-oriented concepts through this project. Polymorphism is one I struggled with, but this project helped me understand it a whole lot better. I come from a background where I make mobile apps, so I thought this would be fun. I make mobile apps and publish them to the Google Play and the iOS App Store. So yeah, if you have any questions about this project or how I did any of this or want to take a deeper dive, I will be happy to answer questions. But other than that, that's the end of my presentation. Let me know what you guys think in the discussion. I will be looking at other projects because I'm very curious to see what my classmates have done. So yeah, that's all I got for you guys. See you later.